I'm going to go over the Regents questions from the January Regents of 2020 that have to do with parallel lines or quadrilaterals. So if we take a look at number 1, they tell us that these two lines are parallel. So since they're parallel, that means alternate interior angles are congruent. So when they tell you that angle FAB measures 48, so does angle BHC. You can look for the Z in the picture. Then they tell us that angle ECB measures 18, and they ask us for angle ABC. You need to remember that geometry comes in layers. This is the one thing I've tried to instill in you all year, is to see that geometry comes in layers. So there's this layer here, which is the exterior angle of a triangle. So X equals 48 plus 18. The exterior angle of a triangle equals the sum of the two non-adjacent interior angles. And that's how you would do that question. So moving on, question number 4 has to do with quadrilaterals. It's about a parallelogram. Make sure you read the question. You need to memorize the properties. You will not be able to do these questions without memorizing the properties. They're asking us to prove that ABCD is a rectangle. You may want to draw a picture first. If you draw a picture, you have to make sure that you label the letters going around like a clock or counterclockwise. So we want to prove that this is a rectangle, knowing that it is a parallelogram. The way you would do that is you would prove the diagonals are congruent, which is choice 1, or you would prove consecutive sides are perpendicular. None of the choices are on consecutive sides being perpendicular. Now remember, geometry comes in layers, so if you take a look at number 6, we have a trapezoid. The trapezoid gives us that these sides are parallel, and they tell us that AE is 5.2. Then they tell us that AC is 11.7. So that means that EC is 11.7 minus 5.2, or 6.5. Then they tell us that CD is 10.5, and they want us to find the measure of AB. So hidden in this picture, we have these parallel lines, so the alternate interior angles are congruent. And then you have similar triangles. So if you look at those similar triangles, we have that triangle AEB is similar to triangle CED by angle. And so therefore you can make a proportion. So X corresponds to 10.5. And then you have go back to X, you have 5.2, which corresponds to 6.5. And then you're going to cross multiply and divide. So when you cross multiply 5.2 and 10.5, you're going to get 6.5 times X equals 54.6. Divide by 6.5, and you'll get 8.4. Okay, if you're looking at the next page, question 9, they're giving you a quadrilateral, and they're telling you AB is parallel to CD. So that means that ABCD is a trapezoid. Then they're telling us, so we have that these are parallel. Then they're telling us that, all right, you have these parallel lines, and they're telling you that you have these midpoints. So E is the midpoint of AD. H is the midpoint of AC. And we have that F is the midpoint of CB, or BC. So that means that EF is a mid-segment of the trapezoid. It's also a mid-segment of triangle CAB. Again, geometry comes in layers. So when they tell us that AB is 24, and they tell us that CD is 18, And then they ask us to find FH. FH is just going to be half of 24. So it's just going to be 12. So if you realized that fact, then you'd be able to get through the question pretty quickly, that is just a mid-segment of a triangle. Because you have CH congruent to HA, you have CF congruent to FB. So hidden in this are similar triangles CHF, and you have triangle CAB. Those are going to be similar triangles, okay, by side angle side, because of this angle up here, reflexive property. At any rate, that's how it works. We learned that way back when we did mid-segment of a triangle. Looking at question 15, this has to do with rigid motion and properties of a rhombus. So in a rhombus, all the sides are congruent. So what that means for us is that CD and DA are congruent. And so that 35 degrees, that's a base angle of an isosceles triangle. So that's 35 degrees. There's 180 degrees in a triangle. That's 110 degrees. And because of rigid motion, angle ADC will map onto angle KNM. So therefore, KNM is 110 degrees because rigid motions, remember this saying, rigid motions preserve distance and angle measurement. So the corresponding angles have to be congruent. Taking a look at number 18, they're asking us to find the area of a rhombus. All four sides are congruent. So that means if we split this in half, we have two isosceles triangles. The formula for a triangle is area equals half base times height, but since a rhombus is made up of two congruent isosceles triangles, if I multiply that by 2, I just get base times height. So I'm just going to multiply the base, which is 1, 2, 3, 4, 5, 6, and the height 1, 2, 3, 4. That's the height, and just call it a day. All right. There's other ways of doing these questions as well, but I try to look for the most efficient way. Taking a look at number 32, you can choose whether or not you want to plot the points. Go ahead, feel free if you wish. I'm not going to plot them. I want to prove that NATS is a rhombus, so I'm going to prove that all four sides are congruent. So I'm going to find the measure of NA, AT, TS, SN. Now you can use the distance formula. I know different people have different opinions, okay? My opinion is that students should be able to get distances between the X values and the Y values using mental math, okay? I know that's a controversial opinion nowadays. If it gives you controversy, use the distance formula. So I'm looking at NA. The X values are 5 apart. Then I'm looking at the Y values, -3 and 2. Those are 5 apart. So I get square root of 50. AT, X values are 7 apart. Y values are 1 apart. TS, X values are 5 apart. Y values are 5 apart. SN, 7 apart for the X values, 1 apart for the Y values. So you can see that all these lengths are the same. No reason to simplify it. No one asked you to, so why simplify if it wasn't asked? So you would just state that NATS is a rhombus because all 4 sides are congruent. That is a sample of a coordinate proof. Every year the coordinate proofs will vary. Taking a look at the final question, This is a regular Euclidean proof. They're giving you information and they're asking you to prove FG is congruent to EG. So it should stand out to you that FG and EG are in triangles FGD and EGB. So I'm going to prove that those triangles are congruent from these other givens, and then I'll use CPCTC. Okay, hidden in this picture now, you have those triangles, but you're also going to have a parallelogram. So usually the proofs on the regions have to do with something to do with parallelograms and triangles, but that's not always the case, all right? But when you do see something like this, it's pretty likely that you'll have something like that. So I would put my statements and reasons. I have statements, I have my reasons. Okay, you're going to write the givens down. So I start off, I have ABG is congruent to CDG. So that means that these are parallel. So I'm going to have that AB is parallel to CD. And that is because I have alternate interior angles congruent. Therefore, I have established that I have parallel lines. Then I have that AB is congruent to CD. And all these givens I would write here. But I'm saving time for this video recording because it takes up a lot of memory when you record yourself teaching like this. So because these sides are both parallel and congruent, ABCD is a parallelogram. And so I would say one pair of opposite sides, congruent and parallel. Then I have a parallelogram. Okay, so knowing that this is a parallelogram, I look at my hints, okay, I call them cookies or cookie crumbs, all right? Like Hansel and Gretel, they left crumbs behind, okay? So CE being congruent to AF is a crumb, all right? Let's follow that crumb. That's going to lead us to find BE congruent to DF because since we have this parallelogram, BC is congruent to AD. Because in a parallelogram, opposite sides are congruent. So now I can use the subtraction property. I can do BC minus EC is congruent to AD minus AF. And at Schreiber, we don't make you do partition and substitution with this. We let you put all this in one step. So therefore, BE is congruent to FD. That's subtraction. So that gives me one set of congruent pieces of those triangles that I had my focus on. Now you can use vertical angles if you wish. I know a lot of you love them. All right. So let's do it. Angle 1 is congruent to angle 2. Vertical angles are congruent. And then we also know that because ABCD is a parallelogram, BC is parallel to AD. Because in a parallelogram, opposite sides are parallel. And therefore, we can say that if you look at the Z, we could say that angle EBG is congruent to angle FDG. So angle EBG is congruent to angle FDG. Because we've established that we have parallel lines, therefore alternate interior angles are congruent. Now I have enough information to prove the triangles are congruent by angle, side, because the sides are not included between these alternate interior angles and the vertical angles. So that's angle, side, or you can do side, angle, whichever, same thing. and then you just use CPCTC and remind yourself what that stands for. Okay, corresponding parts of congruent triangles are congruent. I hope that seeing these Regents problems worked out and hearing my voice in the background helps somebody. All right, thank you.